Okay, so here's a sample problem for us to work with here. I've got some papers to give back to you guys too. Yes. Oh man, I'm all right now and then. Let's see. Today is the 27th, correct? Good. Let me start the, I'll finish passing these out in just a second. Let me go over here and how you guys had a chance to write that down. All right, so the way we're going to approach solving this problem is there's a couple things you need to identify. Now, the problems in this class will get more complex as the semester goes along, but right now we're just identifying two things here. You got to identify an equality statement, and you have to identify a starting amount. Okay? So an equality statement is two things that are implied in the problem that are equal. Okay, so what are the two things that are equal in the word problem? Right. And we're going to write that out as a mathematical equality. We're going to say 44.0095 grams of CO2 equals 1 mole. And MOL is a shorthand. You can write that instead of MOLE. It's perfectly okay. CO2. Okay? Then we also need to identify what the starting amount is. And it's a given amount, some physical amount that's implied in the problem that's given to you, or that you have, or something. I mean, given, have, things like that, words like that are clues that that's a given amount. All right, so what's the given amount here? 210.3 grams. The symbol for grams is lowercase g, not a capital G. Capital G stands for something entirely different. So grams of CO2. Now what do we do with starting amounts? A 100. Yeah. Division by 0 is not allowed until you get to calculus. Anybody here taking calculus? Yeah. Well, I've had college, and I agree. You technically cannot divide by 0, but in calculus you divide by infinitely close to 0. That's what's so cool about calculus. Okay. Or one of the cool things about calculus is all those things you were told all these years you can't divide by 0, but in calculus you kind of do. So don't let me blow your mind there or anything, but you know. Anyway, all right. So what we're going to do here is we're going to write a conversion unit. Now, we do everything in the fractional form here as far as conversion units. What we're going to do to write a conversion unit, this is a conversion problem. We're going to have to convert from one measurement to another. We're not changing the amount of stuff, we're changing how we measure it. Okay, and the way we write conversion units in here is we're going to find the side of the equality statement that matches the starting amount and the units and species of the starting amount. Okay, so our starting amount has units of grams and has a species of CO2, carbon dioxide. Okay, what we need to do is identify what part of this equality statement up here that has the same units and species. Okay, so this has this side of the equality statement over here has the same units, grams, and the same species, CO2. All right, and then we're going to take that side and put it on the bottom of our conversion unit. And remember, you always have to, if there are units, you always have to write them with a number. If there are species, you always have to write them with a number. Okay? Now then, the other side of the equality statement goes on the top. And what we said last week was, if I have two things that are equal, and I put them in a fraction, with one side of that equality on top of the other side of that equality, that fraction is equal to, has a value of 1. Like putting 2 over 2 in a fraction. It equals 1. So what we have here is a conversion unit. A unit can mean 1. And what it does is it multiplies our starting amount by 1. It doesn't change the value. It just changes it to a different measurement unit. We're not going to change. It's like multiplying by 1. Only it changes the units of measurement. Okay? All right. So what we want to do now is to cancel units and species in the same way that you cancel x's and y's in algebra. So the grams cancel out. What else cancels? CO2 cancels out. We're ready to finish the problem now. Okay? And so I have a number on the top here and a number on the bottom here that are measured numbers. These ones, okay, we're multiplying and dividing by 1 just gives you the same number, so we can kind of not even worry about those ones. Okay? They're placekeepers, sort of. All right? What we need to do is get out our calculator, and that's one of the things you're supposed to have today. I hope you have your calculator. All right. You don't have to have a fancy calculator like this. Any a scientific calculator is allowed. This is a really good investment, though. This is the calculator that the science department is moving to. All right, and I get this big, long number. Okay. Okay. Now we've canceled out grams and CO2, but we have not canceled out moles or this CO2. Okay. Now you have to be careful when you're reading the problem up here. It doesn't say moles CO2 here. Okay? But it says how many moles. Well, the only thing we're talking about here is CO2. Okay, so some things you have to kind of figure out. All right? All right, now here's the rounding rules. Here's where the rounding rules come into play. We're going to choose the measured or calculated number that has the least number of digits. So measured or calculated numbers, almost any time you have a decimal place, that's a measured or calculated number. Okay, those are clues. That's a measured or calculated number, and that's a measured or calculated number. We're going to ignore any counting numbers. 1, 2, 3, 4 counting numbers. We're going to ignore those because those are infinitely significant. We're not going to use those in figuring out significant digits. Infinitely significant. So which one of these two numbers, these are the only ones that matter to us as far as rounding off. It doesn't mean that the other numbers aren't important, but in rounding off, these are the only two that are important. Which one has the least total digits? So this is the one with the least total digits, and then we want our final answer to have that same number of digits. Okay? So this has how many digits? 4 that are significant. We'll talk about why the 0 is significant today, hopefully. We're going to count 1, 2, 3, 4. Going to underline from this point on to show that those digits are all insignificant. That's how we show they're insignificant. That's important. You must do it. We're going to draw an arrow to show that we're rounding off. That's our notation, like a plus or a minus or a multiplication symbol or a division symbol or an equal sign. You have to show what operation you're doing. And then we're going to write our rounded answer. Since this is a 5, it makes the number next to it a 9. In this case, it rounds up, okay, because it's a 5 or greater. So our answer becomes 4.779 moles CO2. And to help me out, put a box around it so I know what your final answer is. Won't mark it wrong just because I couldn't figure out in your writing what was the final answer. Okay? Any questions? All right. Here's a practice problem for you guys to work on. You may work in pairs if you will do so quietly, okay? That is 27th. That is correct. So 1.25 grams of nitrogen. Symbol for nitrogen gas is N subscript 2. So there's 1.25 grams of that in 1 liter. The symbol we use for liter is a capital L. So how many liters are there in 249.47 grams of nitrogen gas?